Moving ahead, the next part of the chapter is center of gravity, also called as center of mass. It's very similar. It is the point where the mass of an object is concentrated. Example, this marker. Imagine this is uniform. Now this is cylindrical in shape. So the mass of this, or the weight of it, of this object, is concentrated at the center. So I have a circle or a hollow ring. Center of mass or center of gravity is here. So what is center of gravity? It is the point where mass of the substance or the gravity or the weight of the substance is concentrated. If I take this square, then you will have to draw diagonals, point of intersection of the diagonals. So where is the point of mass located? It is here. So center of gravity, it is the point where the weight of the substance is concentrated, or if you find the resultant moment of force at this, it will be 0. Again, if I draw a rectangle, now you have studied that all squares are rectangle. So rectangle also, it is the point of intersection of the diagonals. If I take a scalene triangle, where is the point of or center of gravity? For this, you will have to draw a median. You know what is a median? Median is a line which joins the vertex and the center of opposite side. So if you draw this, this is the median. Generally we denote by G. G stands for centroid. Next, very important, is cone. Now we have two cones here. The difference is this is filled. Means what? This is a hollow cone and this is a solid cone. If I want to find center of gravity for hollow, from bottom, from the base, it is h by 3. And for this, from bottom, it is h by 4. So h by 3 from the base, and this is h by 4 from the base. Center of gravity of hollow cone, and it is solid cone. Clear? So what did we understand? Center of gravity depends on the shape. If the shape changes, the point where the whole weight is concentrated also changes. Clear? So it depends on the shape. How can you find center of gravity of irregular figure? These were regular figure. If it is irregular figure, say this, just like amoeba. How would you find the center of gravity of such an object? What you have to do? You drill a hole. You make 4-5 holes at the edges, near the edges of the object. Next, drill a hole on a wall and put iron nail. Take first hole and put that in that iron nail and let it settle. So when you put this will start oscillating. Let it settle. Once it is settled, what you have to do? Draw a line. So this is the hole. Okay? Then it will be this way. These are called as plumb lines. Directly straight line towards the earth. Now take the second hole and you do it. After some time, it will stop oscillating. You will draw a straight line. These lines are called as plumb lines. These lines are called as plumb lines. Again, you do with the remaining two. What will you find? All the lines are passing through the same points. So this point is called as center of gravity. So you can even find center of gravity of irregular figure. Need not be regular, can be irregular. Okay? Few more questions we will answer. Where is the center of gravity of this cylinder? What you have to say? So you will draw an axis. Axis will pass through the center. Midpoint of this axis. So center of gravity lies at the midpoint of this axis. Clear? Now, is it necessary that the center of gravity is always within the body? Answer is no. Center of gravity can be outside the body. For example, if you take a boomerang. This is a boomerang, the one which Mowgli was using. Now, boomerang, the center of gravity is somewhere here, outside the body. It is not on the body. Here it was on the body, here it is not on the body. Let us take one more example. Boomerang looks similar to a horseshoe magnet. Horseshoe magnet center of gravity is somewhere here. So it is not on the body. You take another example, a hollow spear, just like a football. A hollow spear, a football, it is somewhere here. It is not on the leather part. It is in the air. So it is not necessary that center of gravity will be inside the body or within the body. It can be outside the body as well. Okay, so we have completed this. Now we'll move to the next topic. Just remember one thing, center of gravity, it always depends on the shape. You might have seen one thing. If you have seen bike race on TV, when a person, so a rider, when he turns right, okay, what he does, he moves towards the other direction. Same way, when he turns left, he will move towards the right. This is just to balance the center of gravity. If you do not balance the center of gravity, chances are there that you will fall. You will fall. If you have seen Science of Stupids, in that every episode, if you see, the host will talk about center of gravity. If you balance the center of gravity, you will never ever fall. But if you do not do it, you will fall. So when I am standing, the center of gravity is somewhere near the navel. But when I am sitting, the center of gravity shifted even below. So it depends on the shape. When I am standing, the shape is something else. When I am sitting, the shape is something else. The center of gravity will change. The next unit of the chapter will talk about UCM. The full form of UCM is Uniform Circular Motion. Now, what is the meaning of circular motion? Circular motion means body moves in a circular path. This is called as uniform circular motion. Body moves in a circular path. But when I say uniform, it means what? It is moving with a constant speed. So body moves in a circular path means, and if it covers equal distance in equal interval of time, we say the body is performing UCM, that is uniform circular motion. Here the speed remains same, but what changes? The thing which changes, it's the direction. Direction changes. So the speed remains same. Speed is same, but direction changes. If speed is same, direction changes, I will say velocity changes. Because velocity is which quantity? It is a vector quantity. Velocity changes. Rate of change in velocity is called as acceleration. So such motion is with acceleration, or you can say such motion is called as accelerated motion. So two things. UCM, the definition, it is a motion in which body moves in a circular path covering equal distance in equal interval of time, or you can say it moves with a constant speed. Next question, give example, give reason that it is an accelerated motion. It is an accelerated motion because the speed remains constant during UCM, but the direction changes. If direction changes, velocity changes. Rate of change in velocity is called as acceleration. So UCM is an accelerated motion. They might ask you to write few examples of UCM. What examples will you give? Example, moon revolving around Earth, or planets revolving around sun, like Earth, Moon, Mars, Jupiter. they revolve around Earth. Around Sun. So it is an example of UCM. Let us take one example of chemistry. Electrons revolve around nucleus. So that is an example of UCM. Clear? Okay. Related to this topic. So Sun is at the center. Here we have the planets. So there is a force of attraction. It is called as gravitational force. But this force is not visible. It is an imaginary force. This force is called as centripetal force. It is called as centripetal force. What is the meaning of centripetal force? The word centri means what? Center. The force which acts towards the center, we call it as centripetal force. The force which acts towards the center, it is called as centripetal force. Okay? Okay. This force is centripetal force and this is the displacement. So planets always will move, or the body which is making UCM will always move tangential. You have studied in maths. If this is a circle, this is the center, the point is on the circumference, then this is the radius. And this is the tangent. It is touching the circle at only one point. So the angle between the two is 90. I am giving you in this chapter because in next chapter we will talk about work. That time, please remember this example. We are going to use this example. So centripetal force, it is a gravitational force, special type of force in which a body which is moving in circular motion, a force which is acting on it, it is always towards the center. Centripetal force. Which is the other force then? The other force is called as centrifugal force. Fugal. If petal is towards the center, centrifugal is away from the center. Centripetal towards, centrifugal away. Clear? What is the other difference between the two forces, centripetal and centrifugal? It's very interesting. Centripetal, as you said, it is towards. Centrifugal, it is away. Centripetal is the real force and centrifugal is a virtual force. What is the meaning of real force or virtual force? Real means what? It is actually present. Whereas centrifugal, it is not actually present. It is virtual, or you can say fictitious. Means it is unreal. Now you will say, if it is unreal, why are we studying? Because in physics, there are few concepts. To understand, to validate those concepts, we assume that there is a force called as centrifugal force. But in reality, there is nothing called as centrifugal force. Clear? Next. Is centrifugal opposite of centripetal? Or is it due to third law of motion? What is third law of motion? Every action has equal and opposite reaction. Answer is no. Because action and reaction is always on the same body. Whereas if you consider centripetal and centrifugal, it is on different bodies. So the answer is no. It is not due to the third law of motion. It is due to few concepts in physics. To validate those concepts, we study centrifugal force. Clear? So there are 2 points of differences between centripetal and centrifugal. Centripetal force, the force which acts towards the center. Centrifugal, the force which acts away from the center. It's a real force. It is unreal or virtual or fictitious. Okay? Now you might think that you have studied centrifugation in chemistry. Right? That is different. That is not due to the force. Centrifugation is the technique in which, for example, mom is making, she's using mixer grinder or mixie we call. Whenever she uses that, you might have seen if she's making chutney, the chutney goes on the wall, so it goes away from the center. So since the idea remains the same, it goes away from the center, hence we say that is centrifugation. The technique is centrifugation, but there is no force called as centrifugal force. Okay? Next. What is the difference between ULM, UCM? What is UCM? It is uniform circular motion, and ULM is a linear motion. ULM is a motion in which body goes in a straight path, and UCM, it is a motion in which body goes in a circular path. Next, here this motion is called as accelerated and this is unaccelerated. Why? Because here in linear motion the direction does not change. If there is no change in direction, there is no change in velocity. If there is no velocity change, then there is no acceleration. So such motion is called as unaccelerated. Such motion is called as accelerated. Understood? So linear motion and UCM, that is uniform circular motion. Clear? Yes. So here we end the first chapter of physics 10th standard. We studied about moment of force, torque. We studied about couple. Then there were principle of couple, principle of moment of forces, and we solved few numericals. Then today we studied about the UCM, ULM, centripetal force, centrifugal force. We also studied about center of gravity, the point where whole mass of the body is concentrated. Clear? Thank you.